Hey everyone, welcome to Type Systems. So I don't know, we haven't talked about this one before. So I don't entirely know what my objective for this is. I guess I'm hoping that all five of you will be able to describe what type systems are all about by the end of this. It's a good place to start. So, all right, I want to start with this. Let's say I have a class called Kennel. And maybe it has a method called like add dog. And it takes in a dog and then does something like an add all sort of thing. This isn't any one language, just an example. So we like push a dog into that. And then and we have another method called rile them up. And what it does is like an all dot each, and then for each dog, makes them bark. All right, that's our kennel class. We can add a bunch of dogs to it, and then we can call rile them up, and it makes each of the dogs bark. What could break this? Something in particular that could very easily break.
Giving it something that isn't a dog, that doesn't know how to bark.
Exactly. So we go, cool, I'm going to make all the dogs bark. But if that isn't actually a dog, this thing right here, that could have been a string, that could have been a Boolean, that could have been null, that could have been whatever. And so we call dot bark on it, and it breaks the application. Ooh. So types to the rescue. If for this to get added in the first place, we're checking that it's an instance of dog. Now we can confidently do that dot bark without any worry about whether or not it's going to break our app. That's what type systems are about. Specifically, we call this type safety. So type safety means that we have confidence that when we run our application, it's not going to break because we asked it to do something that it doesn't know how to do.
So are these like validations for our functions?
These are validations for like basically your entire app.
Okay.
So give me some types that you know about. We know some of these already. Any language.
Number.
Number, Boolean, what else?
Array.
Array.
String.
Blob. Undefined. And null.
Any others you know?
Object.
Is a hash technically different from an object?
Different languages. What JavaScript calls an object is actually more similar to what a hash is in Ruby.
Can a function be a type?
Yep. Any others? When you invoke fetch, what does fetch return?
Promise.
There we go. All of these are examples of types. So, technical definition of a type is the allowed values and the actions you can perform on them. That's a type. So Boolean, perfect example. So for the Boolean type, what allowed values do we have for Boolean?
True or false?
Yep. Not A, not 42. Those aren't allowed values in the Boolean type, only true and false. So those are our values. What kinds of operations can we perform on a Boolean?
I mean, like change state, so change it from true to false or false to true.
Sure. So like negation. What else?
I don't know if this fits in with what you meant by operations, but you can use them within statements that you want to evaluate the true or false. So like if statements, that kind of thing.
Not what I'm going for, but you're on the right track.
And you can do double negation. Like double bang.
Totally. That's just the same one
Yeah.
twice. The
Or equals,
what was it?
like an equals.
Like a comparison. I would buy that. What else?
And
And
Can
an or.
There's probably some other ones, but like that gives us an idea of the kinds of operations that we can take on something that's a Boolean type. Legal values, legal operations. That's a type. Questions so far?
Is type safety like strictly an OOP kind of thing? Because
Nope.
like because the definition of like one of these like an OOP is that like it's an instance of like the array class, right? But like how would you do that in like something like C, like define something like that?
Very nice. So you just hit on something huge. So yeah, we know that something is the Boolean type if it's an instance of the Boolean class. So keep going. What do we know about classes then?
classes all have methods. So like, for example, you can't do like a dot split on an array, but you can do it on like a string.
Yep. So classes must be a lot like
The type.
types. Classes are a kind of type. Not the exact same thing, but in a lot of ways, these share this definition. They have some values. We have some actions we can perform with those values. And in a lot of OOP languages, those get used basically interchangeably. Totally have them in functional languages, totally have them in C. There, you're doing it usually a little bit more directly. And we can see some examples of what that looks like. It does it more similarly to how like TypeScript does it. Other questions about any of the type stuff we've talked about so far? Let's talk about subtypes and supertypes. So we can also make hierarchies of these. Just like we do with classes, we can do that with types too. So if I have a string, let me think of some different types of strings that we could have. They're still strings, but they're just more specific.
Like capitalized?
Sure, like starts with capital. That could be a subtype of string. What else?
It can be like interpolated, like in Ruby you could specify one with either double quotes or single quotes, and with like double quotes you can use like a pound sign to interpolate over it.
Probably not like part of the string type. Think about like more specific strings.
Like an email?
Yep, exactly.
Gotcha. I see what you're saying.
Because an email's got rules to it, right? Has to have an @ symbol in it somewhere. Has to have a dot in it somewhere. Has to have a valid top-level domain. So it's ultimately a string. It's also more specific. What else?
So you talk like maybe a password that requires symbols.
Sure. The password. And you might have like multiple levels of that too. Like, what if you had a weak password, and then you also had a subtype of that that was like a strong password. So maybe this one doesn't have any requirements on it, and this one has lots of requirements on it. But the strong password will also fulfill the weak password. And both of them are ultimately strings. You could have URLs, and then as a subtype of that, you could have a secure URL and an insecure URL. So going down, we call those subtypes. Going up, we call them supertypes. So we say that string is a supertype of URL. URL is a supertype of secure URL. Secure URL is a subtype of URL. URL is a subtype of string. Ask me some questions about that idea.
This looks a lot like inheritance.
What, like a what?
This looks a lot like inheritance.
Yes. Inheritance is a type of subtyping. And just like in inheritance, and this is where we're going with this, everywhere that you can use a supertype, you can also use a subtype of that. So if I have something that's just looking for any old string, I can pass a secure URL into that. I can't necessarily do it the other way around. If somebody's looking for a secure URL, I can't necessarily pass any old string into it, but I can definitely do it the other way around. Anybody know what the name for that is? It's got a super goofy vocab word for it. It's part of a really common acronym in OOP. It's the L. Liskov substitution. That's using a more specific variant of something where a more generic one is expected. And that should be allowed. You shouldn't break the application if you're looking for a string, but you give it an insecure URL. That principle is called Liskov substitution. Any questions about types so far? Hit me. It's Friday, I'm feeling frisky. The ultimate goal of type systems is type safety. Just fundamentally about preventing this from happening.
Can you maybe go into a little bit about how maybe type systems work a little bit different in like a purely functional paradigm?
They kind of don't. It's more different language to language than it is paradigm to paradigm. Some type systems are like kind of weak shit. There's just not that much you can do with them. Other ones are pretty robust. Like TypeScript is a crazy robust type system, like way more than like Java, for example.
Under the hood, how does typing even work in a functional programming though? If like, how do you create that constraint is like of like, oh, this thing has to abide by these parameters. How do you create that constraint in a functional language without a class?
So you can declare types the same way that you can declare variables.
Okay, so some functional programs allow you to do that then. Gotcha.
Yeah, so like in TypeScript's a good example. Go to,
Is it using like that JavaScript type of command like behind the scenes?
yes, it's exactly.
Essentially.
Let me go to my my notes. So, John, the thing that you're talking about is it's like that. So I say that I'm declaring a type called age, and it's just a number. I'm just aliasing another type. And now I can say Kyle needs to be, Kyle is an object that has an age property, and it needs to be of type age.
Gotcha.
And then like, you could also constrain that to like, all right, it needs to be a positive integer. And like, among the ways you can do that are with these things called unions. So if I do this, I'm saying cat or dog or both. That's a type. So I can check something's type that way.
And this would sit within the class of like human, right?
No, this is no class is necessary.
Oh,
You
okay.
do this with like your regular old JavaScript. And so John's question was like, how do you do typing if you don't have classes? You do it more like this. You declare the types explicitly.
With the third one, the cat or dog or both, you don't have to do cat or dog or cat and dog,
Correct.
right? Okay.
Like the specifics of that are like a TypeScript specific thing. But this idea that I can do something like false or true is the part of the type for a Boolean. It's called a union type.
So you would do this when you make the object, right? Like in that specific object, and like this would just allow you to like just set parameters on that specific object's attributes, like a custom data type.
Yeah.
Okay.
So like, this is probably a good example of it here. So I've declared a type. It's something that has this key and could have this key. And then I can also say like, oh, and it has to have this value or this union of values or needs to be a subtype of this other type. These can be whatever. And what this is saying is when you invoke this function, it's going to return something that has that shape. And that lets us do things like know that something can bark. So in typed languages, or in statically typed languages, you write your code, and before it compiles, it goes through a type checker. A type checker goes through all of the possible paths in your application and looks for illegal things. It looks for you doing things like calling .bark on something that isn't guaranteed to have a .bark method. If it sees that that's possible in your application, the type checker is not going to even try to compile your code because it didn't pass type checking. And then after that, it compiles.
All type strong or statically typed languages work in this way, or are there some where like actually under the hood it actually breaks because you don't provide the right type, or is that part of what makes it a type safe language?
Part of what makes it a type safe language.
Okay.
Now, like in TypeScript, for example, this is a completely separate step from compiling it. So like when you run TSC on some TypeScript code, it turns it into JavaScript. And then completely separately, your browser turns that JavaScript into beeps and boops. In something like C, this is all built into the same process, but it still happens.
So a lot of what we're doing when we're trying to sort of make our whatever bulletproof, it's basically to get around the type check.
Yep, you're making your type checker's the asshole. Goes whoa, 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 whoa! Not so fast. It's a bouncer. You can't just call .back on that. It's a mammal. Mammals aren't guaranteed to have a back method. I don't know why I made the guy from Boston, but there you go. And so you might do something like camp bow wow equals new kennel. And then you do camp bow wow add dog. Kyle. And if I've statically typed this, the type checker is not going to let that happen. It would still compile. It's valid syntax. But if I say up front that this has to be an instance of dog, the type checker is going to catch that as not valid logic. Ask me some questions.
And so all of this is basically just about getting that type safety. And this is all about just trying to avoid all of the errors that OOP is prone to.
And like FP, just programming. You're adding another level of safety to your logic. Because if you write valid syntax, it'll compile. But it might not be valid logic. So what happens if we don't have type safety? What happens when we do this in Ruby or JavaScript or whatever? Where do we see it not work?
When somebody actually tries to make Kyle bark.
Exactly. When it's running. Whew. Yikes. So if we can do it while we're still writing the code, that's an entire like dominant family of errors that we don't have anymore. Now, like you still need to be able to figure out what that logic should be. And sometimes that's very difficult to do. But now you're not going to get surprised by an illegal operation while your app is running. Because this first one is what we call compile time errors. After that, it's a runtime error. And that means somebody's using your application and it broke. If we can avoid that, we should probably avoid that. So we can make it a compile time error instead, which is way more preferable.
Didn't Ryan Dahl say something that part of like, did he say it was like $1 billion mistake or something like that? That there's some specific type check that isn't native to JavaScript?
I believe you're talking about null, which null's the $1 billion mistake. Tony Hoare. So here you go. There's the quote.
So how do you make a true, like, I guess, custom type? Like, it kind of seems like all of these custom types are just essentially extensions of the base types involved in the language. Like, is that true? I mean, is there really a way to just add a new type to a language? That's not.
Oh, like you nailed it. Like so the types are going to be based off of the range of values that we can express. And so since those have to be some kind of extension of a built-in type, yeah, ultimately they are. Most type languages have like a couple bonus ones in there. So like a common one. Actually, let me look up the TypeScript type hierarchy.
Why was the null reference check such a bad idea?
So what he's talking about is saying like, all right, you can pass in dog or null. So if you do that, now you're calling bark on null and you don't actually have the type safety that you thought you had. And so like, it's a thing that's very easy to abuse.
Does that kind of go back to like, I remember in some of our early React lessons when we were learning how to set state for the first time and stuff. I think it was like Damon said that if you're thinking about setting state and you're going to set it to null as like an initial state, you should probably reconsider that.
Ding, 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 ding. Yes, because null is a different type. If you're getting a list of Pokemon, all right, well, that's an array. If you initialize it to null, that's a completely different type. So then you end up calling null.map before the things load, and null doesn't have a map method, and so it breaks. All right, in TypeScript, this is the like baked in type hierarchy. And so every string is also an any and is therefore also an unknown. Any Boolean is also an any. Void is an any. Void is when you call a function, but it doesn't return anything. Undefined is a subtype of void.
Why is capital object different than little object?
This is an instance of an object. This is the top level object prototype. So for example, if I make something like that, the type of Kyle is object. There's also a capital O object that's at the top of the hierarchy for anything. So if I look through the prototype chain for that, the prototype for that is capital O object. Kyle's a lowercase o object. This prototype is capital O object. And we even use some static methods on that. And if like you're in mod 1, static method is a class method. They're synonymous, mean the same thing. But like, if I wanted to get a list of the keys in Kyle, I could do capital O object dot keys and pass in Kyle. Keys. And get that back. So that little hierarchy is just differentiating between those two things.
Is capital O object a subtype of unknown, or is it just its own thing?
It's its own thing.
Wow.
It's a JavaScript primitive type.
Could you explain what a prototype is?
Sure. A little less scope for this, but briefly. Prototypes are how JavaScript handles object orientation. There's no classes in JavaScript. There's that keyword, but the classes in JavaScript are just what we call sugar, syntactic sugar. If you're more comfortable calling things classes, they let you call things classes. But under the hood, JavaScript uses prototypes instead of classes. So class, superclass, subclass, subclass. So when I make a new instance of this subclass, it copies in all of the things from its superclass and its superclass. It ultimately ends up being just one thing, but it's going through this entire hierarchy and like copying all the things from its parents. That is class-based. Prototypes works a little bit different. So same kind of structure, except when you make a new copy of this, it doesn't copy all the shit in from these previous classes. It actually, when you look up a property or you look up a method on it, It looks to see if this object has it, and then it looks to see if the prototype has it, and then it looks to see if its prototype has it, and then it looks to see if its prototype has it. That's prototypal inheritance. The huge difference here is when I make this thing in a class, all right, so copied all the stuff in, those can't change. In prototypes, they can totally change because these are just objects. I can change them dynamically. Every second, I can add a new property to this thing in the prototype chain. And then an hour later, when I look up this method or property on it, it can look up through these things that could have had their properties and methods and stuff dynamically added, removed, changed, whatever. There's no blueprints. These are actual real life objects that are, and just like any other object, you can change stuff in them. For example, let's say, let's look up something in this prototype for this. So this has like a toString function on it, and it's in the prototype. So I can call Kyle.toString and it'll do something. And it turns it into that. Check this out. Capital O object toString. So it looked this up. You guys saw me make Kyle. That's the only thing that's on Kyle. But in Kyle's prototype, it has a function called toString. So I can call toString on Kyle, and it's going to look it up. It goes, all right, it's not on Kyle. Is it on its prototype? Hey, cool, it is. I've already made the Kyle object. I can make toString a function that console logs fart. And now when I do Kyle toString, oh shoot, it didn't let me do it. Maybe I got some safety in there. But anyway, that's the general idea, is that those are like real life objects that you can do stuff with. In practice, you end up not using it that much. I think like where prototypes come in handy in like practical JavaScript development is, let's say I have a list of 1 million things. They're all objects and they have properties and functions on them. Okay, so I've made 1 million copies of that function. That's fucking stupid. Instead, I can put that function somewhere in the prototype chain and it can look it up there. Now I only have 1 copy of that function. This is very similar to John's favorite thing, event delegation. Same kind of idea.
Does that save memory too?
That's what it's for. Yep. Same thing if you have some property that's exactly the same on 1 million different objects in an array. If you delegate that to the prototype, you've saved all that memory.
Is this effectively like calling super in a constructor each time? Like you're just getting that
sort of
parent.
idea.
Okay.
And so JavaScript added the class syntax that like has a super and that kind of stuff. Under the hood, it's still just this, but it gives you like a more familiar syntax for it from class-based OOP.
It seems to me like this stuff is really useful to know for writing tests.
For types?
Mm-hmm.
Yeah, definitely. So one of the things that's become popular over the last couple of years is this thing called like trophy testing. It looks like this. So this is Kent Dodds, who's a popular testing guy on the internet. And the traditional testing pyramid looks like this. If you went to my TDD thing, you saw me talk about this. That these are slower, they're more expensive, these are cheaper, they run faster. And so this has been the traditional testing pyramid for 30 years. Trophy testing says, we should probably do more end-to-end tests than that. We probably don't need nearly as many unit tests as integration tests. And static typing takes care of so much of our testing problems that it actually kind of belongs in this conversation. Because yeah, now I don't need to worry what happens if I call a function and pass in the wrong type. If I don't have static typing, I want to know if this thing is looking for a dog and I pass it a string, what happens? What error does it throw? What should its behavior be? If I have static typing, that's an impossible thing. It won't make it past the type checker, so now I don't need to write a test for it. Other questions?
Is PHP type safe?
Is what?
PHP type safe?
PHP has optional type annotations. So, which is to say, no, but you can write it that way. PHP's type system is kind of weak. It was originally dynamically typed like JavaScript is. And over the years, they have added some type kinds of things into it, but it's always felt a little bolted onto the language to me. All right, so last thing, and then I want you to work your brain muscles a little bit. This all seems pretty straightforward. So where does it get hard? I'll tell you where it gets hard. So we had array as one of our types, right? Well, an array of what? How do I say a dog array? So we end up doing that with a thing called generics. So generics are like placeholder values for types. They look like this. Like that. This thing in the little angle brackets. If I wanted to write a type for filter, like the function filter, I don't know what I'm going to get. So I can say things, something like, all right, I have this like type placeholder that I'm going to call T. This is going to take in an array of whatever that type is. It's going to be called array, and it's going to be an array of whatever T ends up being. And it's also going to take in a function called fn that takes in that same type as an item and returns some kind of Boolean. And ultimately, it ends up returning an array of whatever that original type was. So this line is just saying, I don't know what the type is going to be yet. It's a generic function, but whatever it is, this, and this should end up being the same thing. If they end up not being the same thing, the type checker should kick it out.
So in that case, you have an array and you're providing a callback function that's saying each item of this array should return a Boolean.
Right.
And then okay.
Will this function? And that's
It's
how
yeah.
filter functions work, right?
Yeah, that callback function gets called on each
Right.
element of the array. Got it.
But we're not talking about even the implementation of it, just what the type of that function ultimately ends up being.
Yep.
And so then if we're talking about typing functions, now we need to be able to start talking about how do you subtype functions? What counts as a subtype of a function? Let's see if I can find an example of it. Anyway, stuff like that is examples of how type systems can get real fucking complicated. Promises. Promises are a super complicated type of type called a monad. It's like we use that syntax all the time. We don't question it too very much, which is probably a good thing for our sanity. We might say something like fetch something, then this, then this, then this. And then we're going to start having catches. If any of those first three promises threw an error, it should go to that catch block. You can also keep going if none of those threw an error. And then have another catch at the end of that. How on earth does that work under the hood? How would you type that? And like, there is an answer to that, but it is fucking complicated and relies very heavily on some kind of advanced type wizardry. So this rabbit hole goes pretty deep, but, and like the 80-20 power law split of this, you're going to spend 80% of your time with types trying to prevent calling bark on a person or bark on a cat. And then one more thing. With TypeScript in particular, but types in general, another cool benefit to a static typing system is if I know that this is a dog, my text editor can hint to me, by the way, these are the things you're allowed to do with the dog. You got a bark method, you got a growl method, it has a name property. Your text editor can tell you that stuff because it knows what this is. In a dynamically typed language, dog could be anything. It has no idea what that is, what things you can call on it, what properties it has. And so you end up being way more productive in your text editor also, because your text editor can help you figure out how this works. All right, time to work out your brain muscles. I want you to send me a Slack that answers the following questions. What is a type? What is type safety? And why do we care about types? It's like a couple minutes. I want you to Slack me answers to those. Go. All right, send me what you got. Jared Mata got a job. Oh, I'm really happy about that.
Hell yeah.
Great answer, Alan. Outstanding answer, Brian. Well done, Jack. John, if the object is of type car, we will know it will have a honk the fucking horn method. Cool, great answer. Good answer, Christine. All right, solid across the board. Well done,
I was
everybody.
following your Boston theme.
Good job, Katie. All right, I think we understand something about types. Hopefully this was helpful for you guys. Awesome. See you at project presentations.
Thanks, Kyle.